Okay, Algebra 2, this is the second half of 9-3, and it's really like the last quarter of 9-3 because this is really short, the last little bit. Yesterday we did SOHCAHTOA on making right triangles on a coordinate plane and finding the 6 trig functions, sine, cosine, tangent, and all the others. Today we're going to talk about reference angles, and this is kind of a really short, easy concept, but we're still drawing those little triangles that we have on our coordinate plane. It's just we're looking at angles inside of that like little triangle that we build. So same thing applies as yesterday. I'm going to talk about the bow ties, not hourglasses, so I'm going to write them off to the side over here. If they give us an angle in the first quadrant and we draw a triangle, we're going to connect him back down this direction to make a bow tie. If they give us an angle in the second quadrant, we're going to connect him back down this way. Angle in the third quadrant, we're going to connect him up so he makes a bow tie. Angle in the fourth quadrant, we're going to connect him up so he makes a bow tie, okay? Hourglasses, we don't want to do, but I'm going to show you what those look like again. So we've got angle in the first quadrant. We don't want to connect him this direction. Angle in the second quadrant, angle in the third quadrant, angle in the fourth quadrant. This is what our hourglasses look like, and we don't want to do that, okay? We always want to make bow ties, okay? So that's kind of what this little box over here is talking about is, looking at the angles in each one of those quadrants as the bow tie angle, not the hourglass angle, okay? So example 3 is a sketch each angle. We're going to start with a 210 degree angle. So in standard position, we always have our first side as the positive x-axis. So that guy right there. And then we're going to rotate around to 210 degrees. So rotating up, that's going to be 90 degrees. This will give us 180. And then 210 is down here somewhere. Okay. So we're going to make him a bow tie and we're going to look at just this triangle. And when they ask for the reference angle, they're asking specifically for how big is this part right here. We're looking for just that angle. How big is that? Okay. So we know that from here all the way around, we just found was 210 degrees. But if I go from just here to here, that's 180 degrees. So if I do the math and I subtract those, if I subtract 180, that's 30 degrees. And this is a 30-degree angle, okay? If that was confusing, let that sink in. 180 is just from here to here. 210 is all the way through, so it's an additional 30 degrees on top of the 180. That's what our reference angle is going to look like, okay? Now, I'm going to do something else. I'm going to give you... this is example AA, let's call it. And before we do example B, and let's say that we have, I don't know, let's do like a negative, let's do negative 260 degrees, maybe 260 degrees. Yep. So we're going to start here again, like we always do. We're going to go down 90. Since it's negative, we're going clockwise, right? So 90, 180, this would be 270. So 270 degrees is here. That's negative, okay? So 260 would be a little bit less than that. So we're going to draw our angle there. And then again, we're going to make it into a bow tie. So it's going to be a really wide bow tie, because the triangle's really tall, but that's okay. We're still just looking for this angle here, all right? So we know that from here all the way around to that point is 260 degrees. But from here to here is 180 degrees. So we're trying to find what the rest of the way would be. And so we're just taking 260 and we're subtracting 180 from it. And that's going to be an 80-degree angle. Now, the deal is, the reason why I wanted to give this to you as an example was that our regular angle was a negative angle. But your reference angle will never be negative. It will always be a positive angle, and 80 degrees. So we're just looking for, when we're doing a reference angle, we're just looking for that angle that's close to the origin, right? Like how wide is that angle, okay? All right, let's go to B now, and B is a little bit more difficult just because this is in radian measures. So we have to remember how we convert from radians to degrees, okay? And the conversion is either 180 degrees over pi or pi over 180. We've done that before. That's kind of a review, but we have to convert, okay? And the thing that I see here is that pi is in the top for a radian, so I want to make sure I use the one where pi is in the bottom when I multiply. So pi is going here, and 180 degrees goes up top here, okay? That way the pi's can cancel with each other because one's on the top and one's on the bottom, and then all I need to do is reduce. So the 4 and 180 will reduce. 4 can become 1 if I divide by 4, and 180 divided by 4 is 45 degrees, okay? Then I'm looking at negative 5 times 45, which is negative 225, I believe. Negative 225, yes, I think so. Okay, now negative angle again in part B. So we have, let's see, starting here, since it's negative, we're going to go down. So we're going to go 90, 180. This would be 270, and we're going only 225. So we're going just here, right? That's 225 degrees. So from here around is 225. Okay. But I want to find what this bow tie angle is right here, what this part is. And I know that from here just to here is 180. So the rest of the way to make it to 225, I'm going to subtract 180, and that is going to give me 45 degrees. So even though it was negative, my reference angle is always positive, 45 degrees, okay? All right, let's do one more, and let's do, this is going to be example BB, and this is the last example. Let's do negative 300 degrees, okay, negative 300 degrees. So starting here, we're going clockwise because it's negative, so 90, 180, 270, and then 360 would be all the way back around, but I only want to go to 300, so I'm going to go over here. And that's 300 degrees, or negative 300 degrees. My bow tie angle is going to be this angle right here, so I have to figure out what this angle is. And all the other ones, we ended up like subtracting 180, but this time we're going to do something a little different to find this angle. If 300 is from here to here, I want to find the rest of the way to get me to 360, right? So in this case, I'm going to do 360 minus the 300, and that's going to give me a 60-degree reference angle, right? If that didn't make sense, like let that sink in, have somebody else explain it to you, but going around 300 is just from here to here. 360 would be all the way, so I would have to go, an additional 60 degrees more, and that's going to be my reference angle, okay? We're not going to do this bottom part down here or anything on the back side. We'll save that for when you guys are actually taking trig class as juniors or seniors maybe. But you're going to do for homework 9, 10, 11 that's on skills practice, 9, 10, 11. Okay, this again is in radians, so you'll have to convert. And then on the back side, 4, 5, and 6. And 4 and 6 are going to be your ones that you have to convert there. So only 6 homework problems. Just graph them and find the reference angle, okay? And that's all you have to do for homework. You should have already, if you don't, 1 through 3 on this page done and 2, 4, 6, 8 on this page done. Okay, so if you don't have those, you need to do them, and then you'll be caught up for what I have for you tomorrow.